Hi, I'm Anthony Desai. This is going to be our video submission for the GameSort utility that we're submitting. So I'll go ahead and run it. And we'll see we get a loading screen that says parsing data, and then we'll get a window open that has like a sort of main menu. Let me go ahead and move this down a little bit so that we can actually see like most of the screen here. Let's go like that. My camera's kind of in the way. So we can see we get a bunch of unsorted games, just kind of like they're just kind of in there, and we see that there's the title field, a review score, a platform, and then the genres that this game contains. So we can go ahead and we can click any of these buttons over here to sort it out. So we'll go ahead and we'll sort by, let's say title first. It's at the top. So we'll get a loading screen that says sorting by title, in the nice gator blue and gator orange in the background. So we get 4 sorts. We have tim sort, merge sort, binary insertion sort, and stable sort. We use the ranges variant since we're adhering to C++20 standard. And we'll notice that binary insertion sort seems to be a bit of an outlier. It took about 6 seconds rather than the under a second of these other 3 sorts. And that's because it's an O of n squared computational complexity algorithm, since it's got to like shift all the stuff around n squared times. So pretty slow there, but the rest of them perform pretty similarly. We have ranges stable sort as a built-in sort of control algorithm just to gauge how we were doing on the other 2 sorts, or the other 3 sorts. So we see that tim sort takes a little longer than merge sort, and I think that's due to the chunk sizes being a little bit hard-coded. They're just 512 every time. And this is also like not a full tim sort algorithm. It doesn't actually implement the gallop step, I suppose, that dynamically figures out how big the chunk sizes for insertion sort should be. Anyway, once we close this down, we'll see that we're now sorted by title, and we have just special characters to really start. It takes a little while to get through to the alphabetized, or like the numbers, since there's actually quite a few special character titles in our data set. So you see we got to 0 here. And we'll also see that if we click the next thing, sorting by rating, once I get back to the start here, take a second. See, sorting by rating takes a lot less time. And see, now we're sorted by rating, so 9.5 out of 10, 9.45, 9.41, and we have Elden Ring, Super Mario Odyssey, and Baldur's Gate 3. Next thing I'll sort by is genre. So that's going to sort that vector of strings over on the right side there, so it takes a little bit longer. And for whatever reason, these 3 don't have a genre in our data set. It's a little bit weird, but if we scroll past those, we'll see, hey, we now have genres. And they're all going to be first person, but we can see on the bottom there that they're changing a little bit when we, and they're alphabetized when we go further down the page. Finally, we'll sort by platform. This is just comparing some standard strings, so it doesn't take quite so long as the genre. And we'll see that we just have the Amiga OS at the top here, since if we go through my file explorer and we go look at the games, we'll see that Omega is the first one. Note that our number of games is 302,504. And also we are doing some blacklisting stuff to get rid of any games with having the tag adult over here, and also any games that contain Unicode characters in their title, since they look kind of bad when they're displayed in this title column. So close out of this, and we get an exit code of 0. No seg faults here. And we use the Moby Games data set for our data, just because it had about 500,000 games, and after filtering out all of the stuff that we didn't want to display, we still ended up with like over 300,000, which is more than enough for this assignment, as we were only required to have 200,000 data points. So that's about it.